Hello, in this video I'm going to go through a old quiz on sections 6.1 through 6.4 in Algebra 2. So I provided a copy of the quiz in Google Classroom and an answer key, but here's the answers as you go through. Or if you don't have access to those things, then you can write down the problem down, try the problem, and then see how I work it out. So 6.1 through 6.4. Everything in 6.1 works out nicely. I can take the square root of it, the cube root of it, everything works out perfectly. So these are real easy. So there's an invisible 2 right here. This means square root. Square root of 121 is 11. If you have, this is a reference paper that we use, so 121 square root is 11. So all the perfect squares are listed in this column here. And then you take the exponent and divide it by the index. So the exponent is 6 and you divide it by the index 2, so you get x to the third. So it's exponent divided by index. That's kind of the way to remember that. And I sing a little song with it too. All the students know the exponents. E-I-E-I-O. The top number is the exponent. E-I-E-I-O. The bottom number is the index. E-I-E-I-O. You take the exponent divided by the index, you get 3. 2 divided by 2 is 1. Now, anytime there's an even, and then odd result, we add absolute value, and that happens on each one of these. So technically, that's the right answer. The cube root of 64 is just 4. 6 divided by 3, and 12 divided by 3. So it is x squared y to the fourth, because you divide each of those by 3, and then the cube root of that. Now it's odd, even, so we don't have to worry about absolute value. This one down here, we're taking the cube root again, but it's of a fraction. We take the cube root of the top of the fraction, cube root of the bottom of the fraction, cube root of the numerator, and then the denominator. So the cube root of 125 is just 5. 6 divided by 3 is 2. Cube root of 8 is 2. 3 divided by 3 is 1. (256). We look in the fourth column. So here's the fourth column. 256. 4. So 4 is the root of that. And the 12 divided by 4 is 3. And 16 divided by 4 is 4. Even, odd result. We add absolute value just to that one there. Now, in the next section, 6.2, things have to be sorted into what we can take the square root of and what we can't take the square root of. So, make 2 radicals. And we have to think about what perfect square lives inside of 54. So I try different perfect squares. Does 36 divide into 54? No, but 9 does. 9 divides into 54. It's the largest perfect square that does. So we break it up into 9 and 6. There's an invisible 2 here. Does 2 divide into 5? No, it doesn't divide into 5 evenly. So we drop the power down 1 and make it 4, leaving 1 x back there. So we're sorting out into what I can take the square root of, what I can't. Does 2 divide into 10? Yes, so I pick the whole thing in the front. So now the perfect squares are here. This is the junk, the leftover stuff that I can't take the square root of. So it's 3x squared y to the fifth square root 6x. That's typically how we think about that. All right, the next one. Sorting it out into what we can take the cube root of, what we can't take the cube root of. 256. Can I take the cube root of 256? No. 64 lives inside of there, so I can take the cube root of 64. So it's 64 times 4. So 64 and 4. Does 3 go into 5? No. Does 3 go into 4? No. Does 3 go into 3? Yes. So I make it x cubed and x squared because I dropped it twice. This is y squared. Does 3 go into 2? No, and if I drop it, it does no good. So y squared is the junk in the back. Does 3 go into 4? No. 3 go into 3? Yes. Z cubed, z. So then the cube root of this is 4xz, and then junk. cube root 4x squared y squared z. And you might look at that and say, that's simplified compared to that. I'd rather deal with this than that, but yeah, that's the way it goes. Okay, we're going to multiply, then simplify. So we're going to basically multiply it together, then sort it. 3 times 8. Now you can multiply it because it's the same index. As long as it's the same index, you can multiply. Just like these are both cube roots. Now if you have a cube root and a square root, you can't multiply together. So square root, this times this is 24. When you multiply like bases, we add the exponents. So we have squared and x makes x cubed. And then y to the 8th. All right. Then we make the 2 square roots because we're going to split it up into what we can take the square root of, what we can't. 24 is 4 and 6. Again, you take out the largest perfect square. So does the 16 divide into 24? No. Does 9 divide into 24? No. 4 does, though. So you pick out the largest perfect square that divides into 24. So you're factoring it based on what you can take the square root of, what you can't take the square root of. 3 go in there? Nope. So I make it x squared and x. Does 2 go in there? Yes. So I take the whole thing to the front. So I get 2x y to the 4th, square root 6x. The next one, we're going to multiply these together. So 1 cube root, 56, x. Now I can't tell from the photocopy if that's a 2 or a negative 2. I'm just going to go with the fact that it's a 2. This has been scanned and photocopied off, so let's see. 56x to the 3rd, y to the 7th, and z squared. So the x had no partner, so it's x cubed. The y did have a partner. When you multiply like bases, you add the exponents, and then z squared. Okay, now I'm going to split this up into what I can take the cube root of, what I can't take the cube root of, the haves and the have-nots, the do's and the don'ts, the yeses and the nos. 8 times 7 makes 56, and again, you're finding the largest perfect cube, and you're really choosing between 27, so you got 56 here. Does 64 is too big? Does 27 divide in there? No, but 8 does. So you're really choosing between these two numbers. 3 goes into 3, so the whole thing comes to the front. 3 goes into 7, nope, so it would make it 6 and 1, and I can't drop that or do anything, so it goes in the back. This is perfect. This is the junk in the back, junk in the trunk. Cube root of 7yz squared. Boom. Now we're going to divide and simplify. So, kind of the same thing. Let's see. 4th root. I can divide these because they're the same. 3 goes in there. 90 times 90, that would be 96 times. Is that right? I better make sure that I did that right. It's after lunch and all the food's going to my stomach, or all the blood's going to my stomach instead of my head, my math brain. So all the blood's going down to my stomach. 96, yes. Okay, I did that right. So then when I divide, I subtract exponents with the same basis, so it's the 9th and y to the 5th. So there's an invisible 1 right there. Okay, now 96. What lives inside of 96? I really only have one choice. It's either 16 or, two choices, 16 or 81. So it's 16 because 81 doesn't divide in there. So then I go 4th root, 16, and that would be 6 times that. And then does 4 go into that? No, so I make it 8, and then I dropped it once, and then make this 4, and I dropped it once. So now I take the 4th root of this, which would be 2x squared y, 4th root of 6xy. So remember, 4 goes into there, 4 goes into there, leaving 1 and 2. Okay, now I'm going to do the same thing here. We have 490 divided by 5 is 98. So it's the square root of 98. I used a calculator, I cheated. This is a 2, so 5 minus 2 is 3. And then that's a 1 there, so it'd be 6. All right, now, 2 square roots, 49 and 2. There's an invisible 2 right there. Does 2 go in there? Nope. So drop it once, make it x squared in x. Does 2 go into there? Yes. So bring the whole thing to the front. So that's the junk piece. So I get 7xy to the third square root 2x. Okay, now we're going to add or subtract. We are not able to add or subtract this until there's common linkage between the two. So I go 3 square root plus 4 square root. So what does this split up into? 36 and 2, 25 and 2. 25 times 2, that's a perfect square that lives inside of there, and 36 lives inside of there. This would be 6. 6 times 3 is 18, radical 2. 5, that's 5 times 4 is 20, radical 2. How many radical 2's in all? 38, radical 2. So you have this makes them be the same size. You have 20 pieces that are all the same size and 18 pieces that are all the same size. So how many in all? 38. Okay, split this up. Cube root, minus 2, cube root, and cube root. So 8 and 2, 27 and 2. There's not a lot of choices with cube roots, so I've used 8 so many times that I know that it's 8 and then it has to be 27, and there's really no other choices that work. So you get 2 cube root of 2 minus, that's 3 times 2 is 6 cube root of 2. So they have the common linkage between the two. So it's 2 things minus 6 things, negative 4 cube root of 2. All right. Now we're going to multiply. Multiplying is FOIL. And this here, we're going to see the middle term disappear because it's the whole things multiplied together. So we're going to do this times this, which would be 9. This times this, minus 3 radical 2. Then on the inside, we have the same thing, but it's positive 3 radical 2. And then this times this is minus radical 4, which is just back to 2. These cancel out. That's really minus 2, so I put minus 2 and minus 9 together. 9 minus 2 is 7. Alrighty, and the next one, FOIL, this times this, 20. You can't multiply, you only multiply things with the same index. So like 5 is to the first power, 2 is to the first power, but the square root is to the half power. So this times this, negative 10 radical 2, just follows along. Then this times this would be 8 radical 2. And then this times this would be negative 4. Square root of 2 is square root of 4. Okay, these go together. This is really 2 times 4 is 8, so that's really minus 8. So the 20 minus 8 is 12. And then we put together, you owe your uncle $10 because it's negative 10 plus 8 would be minus 2 radical 2. Voila. Okay, you can multiply bases together if the exponents are the same. So this would be 81 to the 1/2 power, which means the square root of 81, which is 9. Here, since all of these are the same, when you multiply like bases, you add the exponents. So it's 1/4, 2/4, 3/4. And that's the answer. All right, almost done. Write in radical form. Oh no, this is a big old quiz, isn't it? Radical form, it's going to be a 5 here and a 3 there, because that's your index and your exponent. Here we're going to write it the other way around. We're going to do a squared and a cube root. Down here we're going to actually evaluate this. We're going to take the 5th root. So we go to the 5th column. So 243 is in the 5th column, and the 5th root would be 3. So basically this is 3, the 5th root of this, and then you square it. 3 squared is 9. Now we're going to do the cube root. You can actually do the cube root of negative numbers. The cube root of 125 negative is negative 5. That's negative 5 to the 4th power. Well, that's negative 5 times negative 5 times negative 5 times negative 5 is going to be positive, and then 625. Because if we have 5 to the 4th power, it's 625, but it's all negatives being multiplied together, so it's going to be positive. Okay, when you multiply like bases, you add the exponents. So we have to add 1/4 plus 3/2. So we're adding the two exponents together. So it'll be 1/4 plus 6/4. So if I double this, I double each of those, I get 6. Now I have a common denominator, so that'd be 7/4. When you multiply regular numbers, so that'd be 6. And then you add the exponents, 6. Down here, we have the square root of all these, because it's the 1/2 power, so it'd be 3x y to the -2. Bring the 2 down to the bottom, cross the line, change the sign, boom. And the last one, when you divide, you have to subtract. So we're going to subtract the two numbers. We're going to do 3/5 minus 2/3. So the common denominator between these is 15. Multiply by 5, so it'll be 10/15. Multiply by 3, so it'll be 9/10. So multiply by 3, and you get that. Multiply each of these by 5, and you get that. So 9 minus 10 is -1/15. So it's the partial answer, or cross the line, change the sign. Oops. So that'd be 1 over x to the 1/15. Or you could write it as 1 over the 15th root of x. So all of these are the same, because it's cross the line, change the sign, and then that's the index, right? And then the exponent would be 1. So any of the, well, either one of these is fine, but you're technically would get rid of the negative exponents. Okay, so that's been the review. Well, review, not so much as the old quiz. And I think I did all the pages. Where'd the first page go? I've lost the first page. Oh, I threw the first page off to the side. So here's the first page. And ta-da, voila!